Hi, welcome to all to this lecture. Today I am going to explain least cost entry method in transportation problems. See here, solve the following transportation problem by least cost entry method. So this is one of the method in transportation problem. So in transportation problem, there are three methods are available for identification of initial basic feasible solution. One is northwest corner method, second one is least cost entry method, and third one is Vogel's approximation method. Today I am going to explain least cost entry method. So the problem is given in the matrix form. So here there are three factories F1, F2, F3 which produces products and supply these products to the different destinations D1, D2, D3, D4 in such a way that we have to minimize the transportation cost. F1 supplies 7 units, F2 supply 9 units, F3 supply 18 units. D1 destination required 5 units, D2 destination required 8 units, D3 destination required 7 units, D4 destination required 14 units. The cell containing the values are the unit cost. So F1 D1 cell unit cost is 19 rupees, 30 rupees, 50 rupees, 10 rupees, like this. Here first we have to calculate total supply. Total supply equal to 7 plus 9 plus 18. Once again 7 plus 9 plus 18 equal to 34. And total demand equal to 5 plus 8 plus 7 plus 14. Once again total demand equal to 5 plus 8 plus 7 plus 14 equal to 34. Here total supply is equal to total demand because 34 equal to 34. Therefore the given transportation problem is a balanced transportation problem. Therefore, the given transportation problem is a balanced transportation problem. So next, iteration 1. So in the least cost method, we have to least cost cell. We have to identify least cost cell. 19, 30, 50, 10, 70, 30, 40, 60, 40, 8, 70, 20. Among this all the cells, 8 is least cost. That is F3 D2 cell is the least cost. Because among the all the values, 8 is least value. So that's why identify this least cost cell. After identification of the least cost cell, find demand value. Demand is 8 and supply is 18 units are available. But only demand is 8 units. So we have to allocate 8 units to this cell. After allocation of 8 units to the cell, demand is 0 because 8 minus 8 is equal to 0, and supply is 10 units because 18 minus 8 is equal to 10. So that means 18 units are allocated to this cell. So that's why here only remaining supply is 10 units only. So here D2 column is exhausted because there is no demand for the D2 column. So that means it is satisfied. So that's why it is deleted for the next iteration. Iteration 2, D1, D3, D4 because D2 is deleted. Only 3 destinations are available: D1, D3, D4, F1, F2, F3. So once again, among all the cells, we have to identify least cost cell. Here least cost cell is 10. To the cell, demand is or requirement is 14 units, but supply is 7 only. So among these two, 7 is least. So that's why we have to allocate 7 units to this cell. Once again, among all the least cost cell, 10 is the least cost cell. To the cell, requirement or demand is 14 units and supply is 7 units. So we have to allocate 7 units to the cell only because supply is available 7 units. That's why only 7 units allocated to the cell. So after allocation of 7 units to the cell, supply is equal to 0 because 7 minus 7 is equal to 0, and demand equal to 7 because 14 minus 7 is equal to 0. 14 minus 7 equal to 7. So here 7 units. Here F1 row is deleted because it is satisfied or it is exhausted. So that's why this row is deleted for next iteration. Iteration 3. So two companies F2, F3, F1 is deleted in previous iteration, and destinations D1, D3, D4. So these are the unit cost cells. Among all the cells, 20 is the least cost cell. Among all the cells, 20 is the least cost cell. To the cell, 7 is demand or requirement, supply is 10 units. So that's why we have to supply 7 units to this cell. We have to allocate 7 units to this cell. So after allocation of 7 units to this cell, demand is 0 because 7 minus 7 is equal to 0, and supply is equal to 3 because 10 minus 7 equal to 3 units. So here D4 column is deleted because demand is 0. That means D4 column is exhausted or satisfied. So that's why D4 column is deleted for next iteration. In iteration 4, we have only 2 destinations D1, D3 because D4 is deleted in the previous iteration, and 2 companies F2, F3. Here supply is 9 units and 3 units. Demand is 5 and 7. So among these cells, 40 is the least cost. So 40 here is the list cost. This 40 value occur in two cells, F2 D3 cell and F3 D1 cell. So among these two cells, where we have allocate maximum units to the cell, that cell is considered first. So suppose consider this cell. Here demand is 5 units and supply is 3 units. So suppose we allocate 3 units here, only 3 units is allocated to this cell. Otherwise, if we consider F2 D3 cell, here demand is 7 and supply is 9 units. So here if we consider this cell, 7 units is allocated to this cell. So that's why we have to consider this cell first, because where the maximum units are allocated, that cell is considered if both are tie values, if both values are tie. So that's why here we consider this cell. To this cell demand is 7 units, supply is 9 units. So that's why we have to allocate 7 units to this cell. After allocation of 7 units to this cell, 7 minus 7 is equal to 0 and 9 minus 7 is equal to 2 and 9 minus 7 is equal to 2. So D3 column is deleted. So next iteration 5, only D1, here F2, F3. So here 70, 40, supply is 2 and 3, only demand is 5. So that's why 2 units allocated to this cell and 3 units are allocated to this cell. After allocation 2 units to this cell and 3 units to this cell, so this is equal to 0, this is equal to 0, this is equal to 0. Summary. So this is the original table. So here all the allocated values are shown in this table. In the first iteration 8 units are allocated. In iteration 2 7 units are allocated. Iteration 3 7 units are allocated, and iteration 4 7 units are allocated. Iteration 5 2 units and 3 units are allocated. So these allocations are shown in the original table. So from this table we have to calculate minimum transportation cost. Minimum transportation cost equal to 10 multiplied with 7 equal to 70 rupees. So 10 is unit cost, 7 is allocated units. Allocated units are multiplied with unit cost, we have to get the total cost. So minimum transportation cost equal to 10 multiplied with 7, 10 multiplied with 7 plus 70 multiplied with 2, 70 multiplied with 2 plus 40 multiplied with 7 units, 40 multiplied with 7 units. Next 40 multiplied with 3 units, 40 multiplied with 3 units plus 8 multiplied with 8 units plus 20 multiplied with 7 units, 20 multiplied with 7 units. So total is 814 rupees. Total is 814 rupees. Degeneracy test. Number of allocated cells equal to m plus n minus 1. M is equal to number of rows. Number of rows. N is equal to number of columns. Number of columns. Here number of rows are 1 2 3 3 rows 3. Number of columns are 4 1 2 3 4 minus 1. So that's why this is equal to 6. Number of allocated cells 1 2 3 4 5 6. Number of allocated cells equal to m plus n minus 1. So that's why the problem or the solution is not have a degeneracy. If this is not equal to the problem is have degeneracy. So here number of allocated cells equal to m plus n minus 1. So that's why the solution is not have a degeneracy solution.